I'm Professor Rad, and today we're going to draw pictures of fractions to use them to allow us to compare whether two fractions, if one's bigger than the other one, or if they're the same. So for example 5, we've got 3 pairs that we're going to be comparing. So the first set, we're going to compare 3/5 with 4/6. So when you're drawing fractions to compare them, you want to make sure that you are comparing them using the same size object. So think of this as like a sub sandwich or a hoagie or footlong, and we're going to cut these each up. We're going to slice them up into different amounts of slices, and then you're going to eat some of one sandwich and I'll eat some of the other, and then we'll see who ate more sandwich, basically. So when you have a fraction 3/5, the bottom number tells you how many pieces you're cutting your sub sandwich up into. So we have to cut this up into 5 equal-sized pieces. So I'm going to do my best sort of eyeballing here about, what that should look like. And the more of this you do, the easier it will become to get them, as equal as possible. Next, we're going to color in the numerator number of slices, so this top one. Because we're going to be comparing, we want to be very orderly about how we do this. So instead of just shading any 3 pieces, we're going to shade in the first 3 coming from the left. So we're going to shade in, there's 1 piece, 2, and 3. So those are the 3 pieces of the sandwich that I ate. Now let's look at your sandwich. So your sandwich, you ate 4/6. So your sandwich was cut up into 6 equal-sized pieces instead of 5. So something that helps me when I have an even denominator is I like to kind of cut it in half and then cut each of those halves up. So half of 6 is 3. So I've got to fit 3 equal-sized pieces here. And then I've got to fit 3 equal-sized pieces here. So that kind of helps me figure out how I'm drawing them. Now you ate 4 slices of your sub sandwich. So we're going to shade in 4 slices starting from the right. So you have 1, 2, 3, 4. All right, so it looks like we both had 2 pieces of our sandwich left over. And it looks like, based on how we drew them, that you ate a little bit more sandwich than I did, right? So these pieces extend a little bit further than these up here. But one of the things I'm noticing is that the pictures are one way that we can compare fractions, but if it's really close, maybe I just, this piece looks a little bit fatter than this piece here, so maybe I messed up in my drawing a little bit. So in this case, when it's really close, I'm going to just kind of put a note in the back of my head as a mathematician. Maybe we want another way other than just pictures to compare. But let's try a few more pictures just to kind of get, the flow of it. So for these next 2, the next 2 fractions, I've got 2/3 and 8/12. So I'm going to cut this first one up into 3 pieces. So let's do that. So it's 1, 3-ish. And then for the other fraction, we're going to cut it up into 12 pieces. So let's see. Well, I can do this. And then like that. And then I can cut each of those in half. So if you know your factors, we did factors before, that can also help you figure out how to break up your fraction bar. But we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces there. All right, now we just have to fill them in. So for the first fraction, we're going to fill in 2 of those bars. So, or 2 of those pieces rather. So that's 1, 2. And then for the other one, we're going to color in 8 pieces. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, and this time it really does look like we each ate the same amount of sandwich. I had 2 really big pieces of my sandwich, and you had 8 really small pieces of your sandwich. And in the end, they pretty much line up right at the same. So one of the things that's kind of interesting about fractions is that you can have the same amount envisioned in different ways. So 2/3 and 8/12 represent the same amount of sandwich that was eaten. So what if we have really big denominators here? Oof. So that just means we're going to have to cut them up quite a bit. So for example, if I think about my factors of 27, I know that 27 can be split up by 3. So I'm going to do that first. So cut this up into thirds. Again, you don't have to do this. If you have a pencil, you could kind of lightly draw in your 27 lines and kind of futz with it a little bit. I'm using ink, so I want to be a little bit more careful how I start to break these down. When 27 is broken down by 3, I get 9. And I know that 9 splits down by 3. What that means is in this piece, I'm going to split it down into 3 pieces. And then each of those, I'm going to cut up into thirds. So, yeah. Okay, and I'm going to do that in this next block as well. I'm going to break that up into 3. And then I'm going to split each of those up into thirds. And then this last one I'll split into 3 pieces and cut each of those into thirds. And when I count up, there should be 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 27. Perfect. And then we're going to color in 6 of those really skinny pieces. So remember, the more pieces you cut up into your candy bar up into, the smaller each of those individual pieces gets. So the bigger the denominator, the smaller the piece is going to get. Okay? Or the smaller the denominator, the bigger the piece. So we're going to shade in 6 of these. So here we have 1, 2, 3, 4, 5, and 6. All right. Oh, good Lord. This next one we're going to cut up into 36 pieces. So I know that 9 goes into 36, as does 4. So maybe what I'll do is I'll cut this up into quarters. And then each of those quarters I have to split up into 9. So I can do thirds and thirds again in each of those. Okay, but notice how each of these individuals is a little bit smaller than the 27ths. And you can see as our denominators get bigger, this process becomes more and more impractical, right? It becomes a little bit more challenging to write all these pieces. I mean, imagine having a denominator of like 500. No, thank you. 36 is hard enough here. Goodness. Okay. And then Now that I've got the 36 there, I'm going to trust my method that I'm not going to count them. I'm going to trust that I got it right. And we're going to color in 8 of those. So 1, 2, 3, 4, 5, 6, 7, 8. All right. All right, so when I look at these two, again, it kind of looks like my 8th out of 36 is a little bit bigger than my 6 out of 27. But again, that could be because of how sort of wibbly wobbly my shapes were. So if I really wanted to do a comparison, one way that I could is to divide it out and see what decimal this corresponds to. So let's try that for each of these to see how good our pictures were to drawing them out. So 3/5 means 3 divided by 5. So that's 0.6, which would be like 60% of the sandwich got eaten. And then 4 divided by 6 is 0.6 repeating. So about 66%. So our picture kind of matches up. This is a little bit bigger than this one here. For part B, we had 2/3. Oh, that is 0.6 repeating. Huh. And if we compare that actually to the 4/6 up here, we can kind of see they end at the same spot of what was shaded in. So 4/6 and 2/3 are the same fraction. It's kind of cool. All right, let's see if that 2/3 is the same as 8/12. So 8 divided by 12, also 0.6 repeating. So our picture for these 3 actually were pretty good because they all gave us the same picture, just broken into more pieces. All right, let's see how we did here. So 6 divided by 27, 0.2 repeating. And let's take a look at 8 out of 36. Also 0.2 repeating. All right, so we can kind of see on this picture, like when I compared these two, it was looking kind of similar to up here where they looked like they were pretty close where they ended, but the orange looked bigger. And that's kind of what I was noticing here. But it looks like because we had to break them up into so many pieces, that may have been why. I'm also now doubting maybe I should have counted to make sure I had 36 pieces. So let's check. We had 1, 2, 3, 4, 5, 6, 7, 8. 10, 11, 12. Here's 20. 30. Nope, 36. So this is what we call human error, right? So mathematically, or at least with our calculator, we saw that these two should be the same. And just because of my human error and not making these perfectly the same, we can see that this is a less than ideal way for us to make comparisons if the numbers are pretty close to each other. If I was comparing, say, 1/27th to like 8/36, then this would be okay. We could kind of see that difference a little bit more clearly. All right, let's add fractions to a word problem and work through one of those together. All right, so example 6 says, suppose Luke and Peter each ordered large pizzas from 2 different pizzerias. Although their pizzas were the same size, Luke's pizza was cut into 12 slices and Peter's pizza was cut into 8 slices. For dinner, Peter ate 2 slices of his pizza while Luke ate 3 slices of his. Then we want to work through these questions. Okay, so it looks like there's information, some about Luke and some about Peter. So to help me see it a little bit more clearly, I'm going to highlight all of Luke's information in blue, and then I'll highlight all of Peter's information in orange. So Luke and Peter each ordered large pizzas from 2 pizzerias. Their pizzas were the same size, but Luke's pizza was cut into 12 slices. And Luke ate 3 slices. Then we have Peter. Peter's pizza was cut into 8 slices. Okay. And Peter ate 2 slices. So one thing that you can do to help you when you are doing word problems that involve more than one person or more than one kind of item is you can use different colors to highlight, or you can kind of make a table summarizing the data. So for example, I've got Luke and Peter here. Luke's pizza had 12 slices, so 12 total slices, whereas Peter's pizza had 8 total slices. Peter ate 2 slices, so he eats 2 slices. I'll use SL to represent slice. And Luke ate 3 slices. So this is another way of organizing information for a word problem. So you can either highlight the data or information, or you can write it out in this manner. I would say this technique or this skill is really important for my statistics classes in the future, because you're going to have lots of information that has the same kind of info, like slices, 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 pizza, 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 right? So you want to make sure you're keeping that information clear. Okay, now part A says whose pizza had larger slices. So there are 2 ways to go about this. We could draw a picture, or we could remember that the more pieces your pizza's cut up into, the bigger the denominator, the smaller the slice. So Luke had the bigger denominator, so his slices were smaller. So that means for part A, Peter's pizza had larger slices. Again, if you don't remember that, you can draw out a picture. So let's draw a picture of the different kinds of pizzas, and to make our comparisons easier, these are going to be rectangular pizzas, okay? So Luke is blue, so let's make a blue rectangular pizza for Luke, and we'll make an orange rectangular pizza of the same size for Peter. Same size. Did my best here, right? Now Luke's pizza is cut up into 12 slices. Three, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. And Peter's is cut up into 8 pizza pieces. I'll cut this into fourths. Then we can cut each of those up in half. I kind of like that. Okay. So we can see that each of Peter's slices of his pizza were a little bit bigger than each of Luke's slices of pizza. So again, this picture is reaffirming what we're thinking about denominators. Bigger denominator, smaller piece. Now, who ate more slices of pizza? Luke had 3 slices and Peter had 2. So in terms of number or amount of slices, Luke ate more slices. So B, Luke ate more slices of pizza. And now part C sounds like it's asking the same question, but it's actually asking a different question. C says who ate more pizza? So not who ate more slices, but who ate more of the pizza? So for this, let's draw out that fraction for each one. So Luke's pizza had 12 slices total, and he ate 3 of those slices. Peter, his pizza was cut up into 8 slices total, and he ate 2 slices. All right, so who ate more pizza? So when we started this unit, I think I said something like mistakes are how we learn and how we grow. And I'm noticing I can't tell. I can't tell who ate more pizza. It looks like they ate about the same. So it looks like they ate the same. So let's check. But we saw before with some of the pictures, it looked the same and it wasn't, or it didn't look the same and it was. So I'm not going to trust my pictures here. Let's do some division. So Luke had 3 pieces out of 12 total. So he ate 25% of his pizza, 0.25. All right, let's try Peter's. So he ate 2 slices, and his pizza was broken into 8 pieces. Okay, so again, 0.25. Okay, so it looks like they each ate a quarter of a large pizza. So our picture's pretty good here. It's leading us to a good conclusion that they ate the same amount of pizza. So nobody ate more and nobody ate less. Okay. Whew, cool. So let's do a few Now You Try problems. So draw out each of these 4 fractions and determine whether any of them are equivalent. Do any of them represent the same amount, or are they all different? In the next video, we are going to talk about what if Luke had eaten an entire pizza and then an extra slice? How could we represent that as a fraction? Or, for example, if you bake a lot, you might be told to use 2 1/4 cups of flour. So 2 1/4, what does that mean? What does that look like? It sounds like it's a mixture of a whole number and a fraction. So we'll see that in the next video. In the meantime, I hope you have a wonderful time making mistakes and learning and growing. Bye for now.